Hey, my name is BJ Neal with Cineverse Technologies. Just to get a little background on who Cineverse is, we do interoperability and interworking for mobile network operators all over the globe. So certainly LTE is a big part of that in our future. I'm the VP of IP Services, IP Network Services for Cineverse, and we've done a lot of work over the last few years to get ready for LTE. But just to mention that we do a few more things than just the networking, interworking part of the packet core portion for LTE and packet cores in general. We also are a messaging gateway, a messaging hub. We do something like 3 billion messages, MMS and SMS messages a day. And we also are heavy in the roaming, settlement, and clearing business. So we play a role not only in what I call sort of the real-time call setup, data call setup, and teardown basis, call-related functions, real-time to get roaming calls up and down on the network, but what I call post-call validation and billing and settlement and all these kinds of things that have to happen in the background to make sure that we get paid at the end of the day. I know as technology guys, we spend a lot of time and effort trying to make sure that we get everything working, only to find out that we haven't quite figured out how we're going to bill our customer or make sure we can monetize things. So we play some roles in all those aspects of roaming, both in 2G, 3G, and most certainly in 4G going forward. So I wanted to say a few things about some of the technology that we're employing to foster LTE roaming. It's very important to us. We want to see more and more LTE roaming as we go forward. And we've spent a lot of time with mobile operators across the globe over the last couple years to facilitate that. I want to talk a little bit about the IPX network. That stands for IP Packet Exchange. So that's a GSMA development that is sort of the successor for those of you who are familiar with the roaming ecosystem. That the previous generations for GSMA was the GRX. That's the GPRS roaming exchange. The previous version of this for CDMA was called the CRX. That's the CDMA roaming exchange. These were built very specifically as closed mobile network operator only clubs, and they did not have a lot of or they didn't have any by design provisions for class and quality of service and multi-service tiers and being able to do session awareness. They were, purely a best effort type network. And the GSMA understood several years ago that we're going to be putting more session aware type applications over these roaming networks, because now we're starting to put packet, voice over packet. We're going to be putting video over packet and so on and so forth. Also, it was envisioned that that would be an all IP environment. So the signaling would be all IP. The bearer traffic for video, the bearer traffic for voice, and so on would all be running over a packet network. So the IP Packet Exchange was built and designed to be the evolution of CRX and GRX. Can handle a class and quality of service and multi-protocol. So at Cineverse, we have POPs all over the globe. We operate in North America. We have 2G, 3G interworking, and for us it's very much a multi-service, multi-application network. I'm going to say a few things about diameter signaling that Anjan, my friend, is probably going to expand on quite a bit more as well, because that is a huge emerging technology that we see for LTE in general, both in the home packet core as well as the interworking functions of the network. So you can think of the Cineverse IPX as a managed IP backbone that connects multiple packet cores all over the planet. Some of those packet cores are still 2G in some cases, some of them are 3G in some cases, and most certainly a lot of them emerging to be 4G. And for us, the IPX was built to be a multi-service, multi-application network. Over the years, through the evolution of 2G and 3G, we used to have operators that would connect to us and they would bring us some 56K links or 64K links for their signaling. They would bring in a separate data connection in to do their CDMA roaming exchange bearer traffic. They'd bring in a separate connection to do SMS messaging and MMS messaging and so on and so forth. We'd have separate VPN connections rolling over to do settlement and clearing type services. And that does not fit an all IP converged atmosphere. So what Cineverse had done over the last several years is we have packetized as many of the services that we have ever provided, made sure that our SS7 network moved toward SIGTRAN. We're constantly making sure it's moving toward diameter and SIP to be able to make it future-proof. So the idea is when you get a network connection from an IPX provider, and whether that be Cineverse or some other competitor of Cineverse, it's built to be a multi-service, multi-application network. Why is that important? Because that's how evolved packet cores are built, right? There's no more TDM circuit switched network elements running around in the EPC, right? There's no more signaling plane. All of the services are converged over an IP network. And as such, we have to be very careful about how we manage the packet flows within your packet core and between multiple packet cores. And we have to pay very close attention to class and quality of service to make sure that we manage the network properly, because we don't have a separate network to run the signaling over, or eventually the SMS or the voice for that matter. It's all going to be run over common network elements going forward. And that's very important, and that's where the industry is going, and that's certainly where the 3GPP is headed, and that's where we are today. In the previous session, there was a lot of discussion about just the sheer data explosion, the amount of data that users are consuming. Not only is the bearer data going over the same network elements, but all the signaling to set up and tear down these calls is actually going over the same network pipes. And if these things are congested with YouTube traffic or whatever tube traffic, we've got to manage the network very carefully. And so IPX most certainly provides a role to do that for an inter-carrier, an interoperability and roaming perspective. Just to give you some background, we've got POPs all over the globe. I think it may be easier if I show you a map on this. Again, we had talked about different technologies, SIGTRAN, diameter SIP. We've got POPs in well connected in the U.S., Atlanta, Philly, Dallas, Chicago, and the West Coast, and so on and so forth. But we also are very much a global global operator, and we've got mobile operators connected all over the globe. So we've got London and Amsterdam connected, Hong Kong, Singapore, and India. We've got connectivity in India as well. This is important because as you think of LTE, you may think about your roaming differently, your global roaming setup differently than you have in the past. We'll probably talk a little bit about spectrum and I won't call it the misallocation of spectrum, but the fact that there's a lot of spectrum confusion and what kind of device types are we going to have and what kind of chipsets are going to be available to allow for roaming. What kind of device are you going to have to be able to enter a roaming agreement in a part of the world that operates in a different spectrum band than you play a role in. So the reason the global interworking and interoperability portion is, I think, very important is because people are traveling more than they ever have, and they want their device to work. They want it to work seamlessly when they go to Hong Kong or when they go to somewhere in Europe. It's really all about the quality of experience for our users. The last session talked a lot about some of the rural carriers. Your users want to have just as good as experience as these big guys as a Verizon user. They want to get to the same applications. They don't want to have to go through weird gyrations when they land in a different country. They want to make sure that they have a good quality experience no matter where they are on the globe. So it's very important that operators think about who their IPX provider is or what their interworking and interconnection strategy is going to be, depending on how they build their evolved packet core going forward. Okay? Forgive me for this. I used to be a network engineer. I'm not so much anymore, but I can't do a deck without having a cloud with a bunch of boxes and network elements involved in it. But this kind of gives you an idea, and we won't go through this in detail. Anjan may speak to this a little bit as well. What the point I wanted to make here is there's a lot of similarity between 3G and 4G. In 4G, you've got your S gateway and your P gateway, and in 3G, that was very synonymous with a SGSN and a GGSN. For the CDMA guys, it looks a lot like PDSNs that are home agents and foreign agents. But the difference in LTE is that there's no longer any SS7 interworking going on between these packet cores. Why is that a big deal? Well, you know, evolving technology is part of the business that we're all in. We're used to that. Our engineers do a good job of keeping up with those kinds of things. But, you know, network quality and reliability is a huge, is a thing that we need to worry a lot about. We are very used to our SS7 networks. The SS7 networks have been setting up and tearing down calls for many, many years. It's a very, very reliable protocol. We all know it very, very well. It's well ingrained into our operations and management and provisioning systems. It's ingrained into our billing systems in some cases, right? And so, lo and behold comes the 3GPP Evolved Packet Core and LTE, and there's no SS7 networking in that at all. So we need to make sure as we build our networks and the interoperability between networks that our diameter signaling platforms and our diameter signaling services are just as reliable as we have known and come to love SS7 in that way. Because make no mistake about it, these protocols such as diameter and SIP are absolutely going to replace the SS7 networking protocol going forward. It's written in the standards, and we've got a lot of customers who are charging headlong down that path today. And John, I'm sure you can talk a little bit more about that. The point, though, is about this diagram is in the past, a lot of this interface that we see, the S8 and the S6A, used to take a separate SS7 network to get from point A to point B. That all now runs over a single converged packet network on either the home or the visited side and the IPX network in between. Okay? Here's some interesting things about what we call our diameter proxy service. So the idea is that we think in terms of this diameter services look a little bit like STPs at the end of the day. An operator will have signaling points that are gateways from his network to external partners. It's often easier and more effective for these guys to go to a hub provider like a Cineverse and other guys so that they can have a single connection to one integrated operator and get connectivity to hundreds of operators around the globe. This is a lot better model for scalability and operations and performance than having to build, you know, 300 individual connections to 300 individual operators on a global basis. So as we evolve into LTE and 4G, the diameter signaling platform looks a lot like a hubbing STP model. And so that operators can build individual SCTP connections or diameter connections into Cineverse, and all of their authentication and authorization, call setup and location update things that still have to happen in a 4G network as they always did in 3G, it's just done over a different protocol. So these are some of the things that Cineverse is doing to foster LTE roaming and help bring LTE roaming into reality as soon as possible. One thing I want to mention about that as well is that LTE roaming is real. We've got at least 6 operators that are running over our network that are in live deployment with LTE roaming today. Now, I'm not saying that it's the full VoLTE with IMS interworking and we're doing local breakout and all these kinds of things, but most certainly it's still sort of a tunnel home model today. But LTE devices are getting registered in visited markets, and they are absolutely doing LTE roaming interoperator today. We've got several live operators on our network today. We've got some North American operators that are roaming with AP. That seems to be, from an international perspective, where we see the most traction so far, is between North America and AP. I think Europe's was a little slower, I think, in their LTE uptake, but it's certainly gaining momentum, and we've got more and more operators always talking to us about LTE roaming and interoperability service. And certainly North America to North America, there's some roaming going on there with different kinds of players as well. One other thing I want to mention about the IPX network is the CRX and the GRX was very much a mobile-only club, where the IPX is designed to invite different kinds of operators to the network to the network ecosystem. In other words, wireline operators can connect to the IPX and get good connectivity toward packet cores. Content providers, that's something that the GRX and CRX had never considered, but it's something that we at Cineverse are very bullish about. There are a lot of application providers and content services that your subscribers that are on packet cores want access to. We could connect those to the IPX network and provide a quality managed interconnection point between a mobile core and some of those applications and content services that mobile operators are looking for. And one more thing I want to mention is that Cineverse, we developed an LTE interoperability lab well over a year ago. We've had something like 19 different operators that have actually done live LTE roaming and interoperability trials in that lab. It was a very successful implementation scheme, actually. There were a lot of operators, certainly in Asia, who went directly from connecting into our lab. They connected their production network into our lab to do some interoperability testing with some other operators, and they immediately moved that into a live interoperability and production network services. So I know that we're talking to Globecomm here and several other operators about joining this LTE interoperability lab. We think it's a very, very good way to help any of you guys that are thinking about what your roaming plans are going to be to go forward to work with us, and we think we can certainly help on the technology side. Just one thing, the benefits to that, we're able to solve some problems. Obviously, there's always some interoperability and interworking functions that occur because operator A doesn't quite configure his network the way operator B does. So, you know, Cineverse actually makes a living at trying to solve those complex problems and creating interworking functions between, you know, disparate technologies. So that's something that can be fleshed out in this lab environment. And we very much start with a lot of the GSMA guidelines to begin with. We look at TADIG and IREG testing applications to start with, and then operators have brought their own testing and interoperability plans into these labs, and we've solved a lot of problems without having to do it while customers are trying to get high quality service. So the idea is let's get very good at this in the lab before we deploy it in a live production environment. So that's a bit of my introduction for Cineverse. Thanks for having me, and I hope to participate in the panel going forward here.
Thanks a lot, BJ. I would like to have Anjan talk about more on the DRE and the DRA diameter routers, the technology that is required to do the LTE roaming.
So, you know, as we know, Cineverse is a pretty major player in this space and enables you to go out and roam. But I'm going to talk about what you need to do on your side to ready your network to connect to somebody like Cineverse, for example, you know, to enable roaming. And so let me, you know, we've been talking about this for, I think, most of the day this morning about how LTE is taking off. There's no question. But what's happening right now is, you know, it's either it's operating in islands where people are just setting it up, or it's operating as, you know, fixed wireless with dongles, or, you know, large operators that are connecting or roaming within their network. That we see as changing over the next year or so, and I think a lot of us, you know, a lot of you over here probably have to be ready for it. So let me talk a little bit about, you know, difference between what you're used to, which is SS7 and 3G and LTE. One of the biggest differences between the two is a typical telecom network was hierarchical. You had elements like STPs that would sit in the network and sort of manage your traffic and do things like load balancing or, you know, congestion management, throttling, etc. LTE comes from a very IP-centric mindset, which is a point-to-point for everything, which is great for speed, efficiency, but also has a downside in terms of actually managing. So if there's a problem in the network, you have no idea because everybody's talking to everybody. It's highly distributed. And we've had some high-profile blowouts. Verizon had some network outages, and they were hard to recover. We had some problems in Telnor as well. And so finally, there was a middle ground. The standards guy said, you know what? We can do point-to-point for data, but for the signaling, we need to have some network elements that can manage this network. And that was the birth of what's called the diameter signaling controller, which in many ways looks like an STP, but, you know, there are differences. SS7 was built for telecom infrastructure. Diameter actually came from Radius, which was a you know, validation protocol for, you know, your computer logins. So, for example, SS7 had built-in indirect routing capability for, you know, the techies out there, things like global titles. You can go in and route your traffic based on a range of numbers. You can do load balancing. that kind of information was at the routing level. Unfortunately, in Diameter, that's not there, so you really have to do a lot of the routing, by extracting information from your application packet. So there are differences that, on the surface may not be, may not sound that big, but when you try to go and implement it, they become bigger issues. So, that being said, let's talk a little bit about, how, what are the similarities. So obviously, as BJ said, end of the day, to do roaming, you have to do the same set of functions. You have to authenticate, you have to identify where the subscriber is located, you have to do location updates, all that stuff is done, but instead of using MAP or ANSI 41, that's actually done with Diameter now, similar set of messages. And essentially, the whole SS7 network has now been replaced by Diameter, which runs over an IP, I'd say a hardened IP network. And as I mentioned, a little bit after the fact, the standards bodies have defined an element called the Diameter routing agent, which does a lot of the routing functions, so all the Diameter messages routed through it. They've also defined an edge agent, which is basically a box that kind of sits. It used to be called a gateway STP before, but essentially that sits in the edge of the network, and that becomes your single point of presence to the rest of the world. So essentially, without a Diameter edge agent, you'll have connections from your, all that complicated diagram you showed, all the, P gateways, HSSs, everything is direct connected to the core, to somebody else's network without an edge agent. With an edge agent, you provide a single presence or a single view to the outside world. So that gives you the ability to mask your network, and you don't have to modify or update routing tables throughout the geography, as you make changes on your side. So that's a very key element of the new architecture, which is Diameter Edge Agent. The third thing, which is a key element, is also interworking. And interworking is essentially, as the world moves on, it's, you're not going to have LTE everywhere, so you will have to, in certain markets, fall back to 3G. Unfortunately, they speak a different language. They speak SS7 and MAP, so somebody has to sit there and do that translation. That is another function called interworking function that's been defined by the standards bodies as well, and that also can go into this box. So combination of all these capabilities is defined as a Diameter signaling controller, DSC. We have a product in this space, and our product is called the Diameter routing engine. Happy to say that if you are a Globecomm customer, you should be able to use this shortly. And a lot of people think of roaming just in the context of a phone, and I'm moving from zone to zone, but it's also applicable for data roaming. So if you have a dongle and you can only use it in your home network, if you want to go to your friend's place, and today you can't use that. But if you are a Globecomm customer, as we do the deployments, as you move from zone to zone, you can use the same dongle, and we can authenticate against the central database, and give you that capability, provided obviously the carriers get the interworking and their own business agreements in place. So we're very optimistic, and we're very happy to work with Globecomm in that area. So this is kind of a network, maybe a dumbed down version of what BJ just showed. So essentially, you see all these network elements, and you have a device. There are a couple of ways you can deploy it. You can deploy it within your core, or you can deploy it on the edge, outside the core. And there are two deployment models you can use. You could use a hosted model where a third party is really deploying your edge device for you, and you're connecting to the third party, or you can own that edge device and have a peer-to-peer connection with somebody like Cineverse. And there are pros and cons of both. Obviously, the advantage of having a point-to-point connection with your IPX provider is you can do things like local breakout and features capabilities that you may not be able to provide otherwise. Okay, so this diagram a little bit shows different type of mobile operators and how you would roam. So you could have a hosted DEA, so you're hosting it, and then you connect through an IPX and go to your partner your partner deployment. So essentially, you could do a local breakout. So you could whenever you need to go outside, you could go through an IPX vendor, or if you have a peer network right next to you, you can do a breakout and go right next to it, without having to go through an IPX. So there are different deployment models. Next slide talks about legacy interworking as well. So this is the scenario where you have, this is a 3G to 4G roaming. It's a little bit more complicated. This is where, and this probably will take a little longer as IMS gets deployed and you have VoLTE in place. But reality here is that as you move either way, so when you have, when you're at your home is a 4G operator, you move to a 3G network, you turn on your mobile phone, there is no 4G in that market. So at that point, you're locked onto a 3G and you have, SS7 messages coming in and you do interworking. Same way, if a 3G operator, and that's an interesting use case we heard where there are a lot of 3G operators not planning to migrate to 4G, but some of their subscribers, so for example, from Europe, coming to the US, they want to use 4G when they're in the US. So they have a reverse where at home they don't have 4G, but when they're moving to the US, they want 4G features. So that's a reverse scenario where you're in the US and you're actually using 4G. So that's another interworking in the opposite direction. So, quick list of benefits of having an edge device in your network. One is topology hiding, very key. Essentially, you don't want the outside world to have a full view of your network. So you want to have something like a natting capability where, you become the face to the outside world and everything is routed to you. So the outside world views that single box as your HSS, your P gateway, your S gateway, whatever, your PCRF, and then the smarts is in the box now then to route the message to the appropriate endpoint. Local breakout, which is also another key where you might want to say, hey, my neighboring networks, I want to just do direct peer-to-peer roaming with them. Whereas, in some other cases, when I'm going farther away, I'm connecting to the IPX. So that's a local breakout. Legacy interworking was the third point I talked about, where you do 3G to 4G roaming. And obviously load balancing, which is a smaller issue, less of an issue for smaller operators. Load balancing is where you have 5 HSSs and you want, zonal load balancing for the East Coast, West Coast. Obviously, that's less of an issue. But these are the key features, capabilities we provide in our box. So finally, let me add one more element to this. So with Diameter, everybody's been very focused on routing and, but there is another key element in Diameter as well. There's a lot of smarts that goes to this network. So for example, I can identify when an iPhone gets turned on in your network. I get a message with the device type says, hey, iPhone gets turned on. I know, you can say geographically, I want to know all the iPhones getting turned on at Atlanta Airport, for example. You can set a trigger, and we will notify you. So you could and you could do a whole lot of things with things like with the information like that. You can do different billing. You can do specialized advertising, what have you. So there's a lot of capability that's we give an example of one where as subscribers pop up in different parts of the network, we give you visibility so you can do some network planning. But there are we provide you the capability to bring a lot of these applications to market by providing you the core information that you would need. And we're partnering with a number of app vendors, that sort of need this kind of information. So again, there's a way to monetize the network using a box like that. And as long as you have some creative ideas, we provide you a way, provide you the information for you to monetize the network. So that's the tool we provide as well. So once again, we're very pleased to work with Globecomm on this, and in the next month or two, I think we're going to bring the system live and working with, and obviously there's our partner Cineverse is going to allow connection to the outside world. So we're very excited, and again, thank you for inviting us, Gopi and George and Ken and the team. Happy to answer any questions after Chip gets his chance to say a few things. Thank you.
Thank you, Anjan. So as Anjan said, we are deploying these solutions for our customers who are using LTE services, and we plan to connect each of them if they are in the same band. So with that, I'll let Chip take over.
Hi, good morning, everyone. Thank you for the invitation. Appreciate the opportunity to speak for a few minutes. I'm just going to provide a very, very brief overview of Mosaic Solutions, our place in the market, and some of the services that we provide not only operators, MVNOs, and other software and solution providers. So generally speaking, we have a talented geospatial team who has access to a very large data set. The data set includes, specifically for this audience, mobile network coverage patterns worldwide, by operator, by technology. The database currently has about 1,500 coverage patterns, nearly 900 operators now in 225 countries. It's a big data set. We validate it once per quarter at least. In certain emerging markets, like for example, our emerging technologies, for example, like with LTE, we're updating the data set faster than that. And we take this data, and with what I call the 4 pillars of our talent, we can deliver different types of solutions to our customers in disparate ways. One of the original ways that we supported the wireless industry is going back, for the kids in the room, you won't remember this, but back in the Wayback Machine, before roaming was just worked, there were things called roaming guides, and you actually had to instruct your device specifically with dial digits when you roamed into another network. So we actually printed this. It was a printing business primarily known as American Roamer, and that was the initial types of roaming services that we provided to the industry. Over the years, though, we kept our core capabilities and the creative design team that we have, and developed on top of that more and more and more sophisticated capabilities. So we have significant creative capabilities today. We have interactive mapping applications that, like Google Maps or Bing Maps, we have our own mapping stack. We have our own we have our own geocoder that we can extend interactive mapping services inside of our customers' websites. So fundamentally, our 2 primary things is we help customers make better decisions with better business intelligence, and we help them attract and retain more customers. So our team is really unique for a company of only 40 people. We have a graphic design team, we have a significant market research team, we have a software development team, of course, and we have a really, really talented geospatial or GIS team. So we take the data set, and based on how the customer needs to consume it, we can flexibly deploy it. So we can create beautiful imagery to use in retail stores. We did that for many, many years. As I said, we can create interactive mapping platforms and APIs so that you could ascertain, based on certain elements of data, what's going to happen in a particular area. For example, if you're looking to deploy, you're looking to sell an LTE device to a customer in your network, you might want to understand where the parameters of that network are going to reach them for their particular use case, okay? So you could intersect the data sets with tools that we have to say, okay, live, work, play, right? You have, I work here, I live here, I have a mountain cabin here. Am I going to be able to use this extraordinarily expensive device that I'm inevitably subsidizing for the customer? Are they going to be able to use this device where they think they're going to be able to use it? And it can modify the behavior on the front end to save the operator money. That's just one example. So I think that getting to the coverage catalog real quick, not only do we have the mobile network coverage data, but in the United States, we have a very deep data set cross technology. So we have access to wired broadband data sets. We have access to fixed wireless data as far as where these networks are, cable service areas, et cetera. So as you're evaluating the competitive market, and as you're evaluating what plays you can make in the market to add scale by making an acquisition, if you're looking to edge out your networks, we've heard a lot today about operators who have multiple types of technologies, and because of the flexibility that they have, they can deploy a specific type of product to a specific constituency, understanding who owns the spectrum in that area, who's providing what type of service in that area, what are the demographic characteristics of that area, can help you make better decisions about where you point specifically some of these new wireless networks that are online. So it's obviously a zoomed out view of our global data set on the mobile side. As I said before, it takes a lot of research and a very symbiotic relationship with the operator community. We recognize that it's in the best interest of the serve operator to make sure that the home operator knows whether or not their customers can use their device, right? Expectation setting is very important. If you don't set the proper expectation on the front end about establishing where your footprint is, where your roaming networks are, whether it's in your backyard or globally, you can inevitably wind up with an unhappy customer. And generally speaking, if the customer knows they're not going to have service because they're going on some safari in Africa, they're not upset if they don't. But if you set the expectation by giving them an international roaming package or by renting them a particular type of device when they leave, and then you don't provide the service, that's when you wind up with an unhappy customer. So as I said before, we have several types of networks that we track in the United States. This is a growing market for us as we are starting to figure out more about what types of groups find this information valuable. And we're always looking for new data sets, always looking for new opportunities to go into new areas. And the wired broadband information is something that we just got into the last couple of years. And it's interesting to see, especially in the rural areas where the competitive market is in some cases becoming much more simple. You have to be much more creative about how you go about marketing your services and how you go about making your investments. And having access to this type of intelligence certainly is not the end-all be-all to your business case, but it is one data element that can help you make a better decision. So this is a very high-level overview of sort of the types of solutions that we support. We have the coverage catalog that sits on top, and then there are different verticals that we support. So for direct to consumer, which is really B to B to C, right? So we're selling our services or licensing our data sets to other businesses who are then marketing directly to consumers. We have our interactive mapping platform called Cell Maps. It's a tailored application so that we actually take the interactive map and we take all of the data as directed by our customers. So for example, you say, here are the 500 roaming partners that I have worldwide. I go out and do all the market research. I aggregate the coverage to your specifications. I make it the right color. I include whatever technologies you want to include, and I slide it inside of my interactive map and slide it into your website. But it doesn't really end there, because ultimately this is an extension of your brand. So we actually do all of the creative design work to make sure that it matches with your corporate brand standard, okay? So this is how we're different from other traditional mapping providers who will just give you a map and then walk away. We actually work with you to make sure that creatively it looks great and functionally it gives you everything that you need. As I said before, we still do a lot of mapping. If you're coverage mapping, if you see a Verizon wireless coverage map, or if you see a Rogers coverage map, chances are, even today, we made it. We work very closely with a lot of people, including many rural operators, to help them market their network more effectively. On the SaaS side, we can certainly extend our interactive mapping platform for back office applications. We do network monitoring. We do churn reduction applications where we try to give tech support reps or care reps more information on the front end so that they can solve their customer's problem faster. We have an application called Map Elements, which is a browser-based mapping application that it's basically a light GIS SaaS. It's certainly not as feature-rich as some of the other ones that you'll see on the marketplace, but by design, it's intended to give decision makers access to business intelligence so that they can make decisions faster. A lot of software companies try to get their users, their value proposition is centered on getting their users to spend a lot of time working with their software. Ours is actually a little bit different. I love to see my users, as they're coming in and doing some work in Elements or in Map Elements, and then bouncing out and getting on with another piece of the business case, right? So Map Elements takes all of the data sets that I've described and exposes them to the user and gives you very rapid capabilities to intersect the data sets based on geographies, based on simple queries, to get you the answers that you're looking for. So for example, if you wanted to know the spectrum depth in a particular CMA, you simply intersect that CMA, and in about 5 seconds you're going to see everything that's available in that particular market. You can then work with the data sets geospatially, do a compare contrast against them, understand where they overlap, where they don't, and you can see demographic characteristics underlying as well. Real quick, we expose some of our APIs on coverage validation, which is the service going to be available at this location or these locations? And then we have a tiling API. As I said earlier, we try to flexibly offer our services. So many customers have their own geospatial stacks, right? And that's fine. If they want to have access to my information, but they still want it to be hosted, I can actually extend the coverage data via an API and have it just sit on top of their geospatial stack, right? So either way they want to go with it, we try to be very flexible. And finally, all of the data sets are also available in GIS file formats, right? They're in .tab or shapefile, whichever you prefer, so that you can actually work with the data sets along with all of your data inside of your GIS software. So that's really it. I just wanted to offer a brief overview. We've been involved in roaming for a long time. I worked in roaming strategy for Alltel for 4 years. It was interesting to hear the comment earlier. And I think that it's really interesting to see where we are right now and where hopefully we can try to solve or correct some of the mistakes that we've made in the past to try to make sure that the roaming networks are developed. And I think developed is an important word, collectively, so that we can provide as much value to the end users as possible.
Questions? I have a question for Cineverse. The question is, I heard in some of the discussions that AT&T is starting to explore the 4G roaming with some of the rural guys. The question is, how are they going to price this? Because for the rural guys, the backhaul is very expensive to connect back to these guys, and LTE needs really high-speed connections back to the home network.
So the way they would price it on an interconnection agreement. Can you guys hear me okay? You know, I'm not really privy right now to what an interconnection agreement terms might look like between any operator and any other operator. I mean, we do have exposure to that in our settlement and clearing business, and that's part of why we're a trusted third-party intermediary that can see that data. But you know, certainly I can't talk about what some of those interconnection agreements look like today. I can say though that the idea of Cineverse being between or in the middle of some of these operators certainly makes it much faster for them to be able to roam as soon as possible. If you can imagine a large carrier having an IPX connection to Cineverse running multiple services on it, including 4G roaming, and chances are another North American operator may have that same connectivity already in place for legacy services such as CRX and GRX. See, that's the point of the IPX network, is it's future proof. Because you can use the same network to do your legacy CRX roaming, your legacy GRX roaming, your legacy SIGTRAN services to do authentication and authorization, as Anjan said, but it's the same network connection. We can start advertising the routes of our diameter proxies. We can start advertising the routes of LTE S gateways and P gateways and MMEs across that same connection, and there's no need to wait for fiber builds to occur, or the typical wait time that we think of when we have to upgrade network connections. Now, to the earlier session, that puts a little pressure on making sure that we have enough bandwidth to do all these things, right? So if I put in an IPX connection and all I'm running on it is some signaling, I'm certainly not going to run the S8 LTE bearer traffic over that. But usually when we work with these customers, we sort of plan ahead in this way and say, what do you need this connection for to start with? Let's make sure we get those services up and running, including messaging, signaling, steering of roaming, all kinds of different applications that we like to layer on top of the IPX layer, right? And then make sure we know in a year and a half from now, we should certainly start to see diameter signaling, SIP signaling, and other new emerging services and technologies. So, how operators think about negotiating interconnection agreements today, and how LTE changes that view, or 4G from 3G, is not something I can answer, but I can certainly say that we can provide the technology to make it happen a lot faster, and I think we've done that quite a bit.
I have a question on the rebound. Yes. So, BJ, question on the rebound for you on this one. So when we probably talked to a lot of the folks that you talked to in terms of enabling roaming, one question I come across is, so given that Cineverse has relationships with hundreds of operators, dozens at least, 900, well, there you go. So do they, if they connect with you, do you have a default routing agreement or a default roaming agreement with these guys that they can piggyback on? Or do they have to go and, you just enable them, but they have to go cut separate agreements again with 900 operators?
Yeah, That's a great question. We have several services in our portfolio, and again, as we said, IPX. There's some operators that buy, every imaginable service that we can run over that pipe, right? And a lot of the smaller guys and smaller operators tend to be like that because you guys wear a lot of hats and you're able to make a lot of decisions. You're able to move much faster than some of these big guys. That's a big advantage for you guys, by the way, that I think is something that is very exciting for you, is you're able to make technology decisions and make them happen way faster than a lot of these big guys out there. But yes, and especially in emerging markets, so like Africa, for example, and some of these emerging markets, what we typically do is we have already gone through all the IREG and TADIG testing that occurs. It's all GSMA standard. We can sort of outsource that in a lot of ways to a lot of these customers to shortcut the interconnection agreement process. At the end of the day, there is going to have to be a commercial roaming agreement of some type between operator A and operator B, unless you're operating in sort of a roaming hub environment, which we also support. So there's various ways in which we shortcut that interconnection agreement process, either by doing some professional services type stuff and using past interconnection agreements and sort of reformatting them to the newest operator's needs, or by just offering a sort of a roaming hub service where they can come to Cineverse and go to sponsor operators and sort of be roaming very quickly. Uniroam and sponsored roaming are other variations of some of these bilateral roaming agreements that we certainly support and that we have been involved in with 3G for many, many years, and we'll expect that to continue in 4G. Difference is a lot of those things rely on processing of SS7 messages and all those things, so we got to do a lot of work to make sure that all those same value-added services like steering of roaming and those kinds of things are now compatible with a whole new protocol, which is diameter, or eventually it'll be SIP, something of that nature. So as with everybody in the technology business, it's a constant struggle, right? As soon as we build something good, we spend a lot of money and, create happy customers, we got to do it again because there's some sort of pressing need to go bigger, better, faster, and harder. And LTE is a perfect example. One more thing I'll say about that is, you touched on this earlier, is full worldwide, global, ubiquitous LTE 4G is going to be a ways off, right? And Anjan talked a little bit about interoperability and making sure that we don't oversteer our headlights and making sure that we make things backward compatible to 3G. Interoperability to 3G networks is going to be around for a long time. And that's good news, right? We've made a lot of investment in our 3G networks. I mean, they still got a ways to pay, right? And although we're being forced down the 4G path, I think 3G is going to be around a long time. So as you think about your roaming and interoperability needs, think backward compatibility, because there's no doubt going to be places and cases where no matter how brand new and state-of-the-art your LTE network is, when your guy steps off a plane in a different place and it's not the latest and greatest, the things still have to work. And so building backward compatibility into everything that we do going forward is a very important part of our business, and some things that you guys and Globecomm can help you think through.
Hi. Does Cineverse provide roaming for Wi-Fi networks on a global level? Is there any Wi-Fi support that you provide?
Yeah, we have a Wi-Fi sort of clearing and exchange type service. It's something that was kind of modeled after our CDMA mobile data roaming service because it's happens to be radius and AAA oriented. So we absolutely do have that as a service. We've got operators who connect to a lot of the aggregators, and we do a lot of the authentication, sort of the middleman authentication services between mobile operators and other operators who have not traditionally been in the mobile space. So we got cable guys that are out there putting Wi-Fi networks in. And, I think there's a little room to grow there because, we want this handoff between cellular and Wi-Fi to look more and more, homogeneous. You don't want to have to be clicking a bunch of buttons and putting in passwords and all these kinds of things. So, I think as Wi-Fi offload becomes more of a longer-term strategy to handle capacity issues and so on, services like that will become more important to make it look like a ubiquitous and seamless experience. We spend a lot of time researching what role we could play there and trying to think of some of the experience that we have in roaming and interoperability for cellular and how we can apply that to Wi-Fi. Got a few things, but we got a lot of work. I would admit that we've got a lot of work to do in that space.
So typically when you do Wi-Fi roaming, is the exchange rate of dollars per megabytes different between 3G, 4G, and Wi-Fi? Or do you see that typically operators use the same exchange rate?
That's a good question. It's a tough one for me to answer. I don't have the answer, but I would say this. I think the model's a bit different, right? Because imagine this: if you're roaming on somebody's Wi-Fi network, that hotspot is pretty locally connected to an internet fiber connected type of connection, right? So it's not like, I mean, yeah, you're operating a hotspot, right, on unlicensed spectrum. It's not like you've got too much to be able to charge on this sort of cellular tower backhaul. So I should be careful. My guess is that the interoperator tariff rate elements on a Wi-Fi sort of basis, on a per meg or per whatever unit basis is, would probably look a lot different than it would be in a cellular territory.
Yeah, so my experience on the Wi-Fi space is that currently they're completely different types of networks run by completely different types of professionals inside of these companies, even if they have both. And they're starting to modernize and they're starting to get a little bit more engaged, but the Wi-Fi community today is very, very much operating on independent islands. And there's certainly the WBA and some of the other organizations that are trying to start to herd the cats a little bit with them. But it's very, very early, and you know, the AT&T Wi-Fi team versus the AT&T mobility team, I don't know that there's a whole lot of interaction between the two. They're certainly trying to, you know, have some synergies with one another, but yeah, the cost of the networks are so much different. And you're also, speaking of unlimited, and we were talking about that earlier, and on the tariff side and data caps and things like that, customers are used to being able to use unlimited Wi-Fi for free, right? Certainly in Europe, and so now trying to apply some pricing restriction on that market is proving to be difficult.
I have one question to Chip. The question is, do you have any data set point that could be useful for the rural guys to find out who could be their potential roaming partners in the 4G LTE play?
Absolutely. So certainly we have access to not only what spectrum everyone owns in the market, what by band, by block, et cetera, with a great deal of detail. And we certainly know where the networks that they have deployed are. So you marry those two things together and pick up the phone. One of the interesting things, we were talking earlier about all the M&A activity, it's been fascinating for me to watch the industry come together because there's been so little rural M&A activity, right? And the rural operators need scale. And they need to, it's a chicken or the egg problem with vendors, it's a chicken or the egg problem with device manufacturers and with consumers. And so, yes, we have a lot of capabilities there to be able to either provide just one-off data sets if they're looking at a particular evaluation, or provide more holistic, like licensed subscriber-based services so that they always have access to information that's maintained frequently.
One of the challenges roamers have in 4G is their apps. Their apps are always on. They're chattering away. They're doing things that are running up a bill. Yeah. Many roamers turn off their phone when they're out of their coverage area. But there are ways to mitigate this. And I don't need to have all my apps being updated while I'm in Bermuda next week when I go on vacation. I don't want to turn my phone off either. I'd like to be able to have a middle ground where I can use the email applications I want, I can get calls, but I don't have to have all my apps on their own doing all this stuff. I like using Angry Birds once in a while, but Angry Birds can run up a huge bill for unnecessary reasons. What are you guys doing to help both the operators help their subscribers and then help their subscribers just to manage that?
Did I give that a go?
Yeah,
quick. Thanks. Great question. That's a more and more important aspect of our business going forward, Barrage. We have a specific product that we call Data Roaming Engine, where we actually have a GTP proxy, if you like, that sort of sits between the visited network and the home network, and there's a policy engine in there, so that we can pull the GTP traffic out of there, and it's almost a deep packet inspection type situation, so that we can, by subscriber level, give them data packs, right? So we can offer a user a day pass, for example, for a day for an X amount of dollars that would only go up to a certain amount. Because, like you said, what we call them the silent low spenders are these people who are so afraid that they won't turn on their phone, when they roam. So at minimum, we can at least offer them a way to at least give them some protection that they're not going to run up a ridiculous bill. Yes, yes. The operator can do that from his home operator, but because we're in that roaming path, it can work in a roaming environment because we can monitor that, and we can know exactly how much a subscriber has used while he's turned on his data pack, so to speak, and we can do also use of charge, notification of charge, so we can send SMS message to that user to let them know that they're reaching certain thresholds while they're roaming, and it's another form of sort of deep packet inspection and policy management, if you like, that sits between the visited and the home, which puts us in a very unique place to be able to provide services like that. Very big part of our business going forward, and something we're getting a lot of traction on and looking forward to. The silent low spender problem is a big deal for us.
I'm with Cineverse as well, and one of the things is with BJ's talking about is you got to identify that customer quickly. The silent low roamer, what they're doing is they land, they put their phone on, and then they shut it off. So the key is you have a very short window, and we have tools, and there's tools out there that target them right away. Work with the operator to hit them with a SMS message immediately and let them know about the values, and that they're not going to necessarily get into this usage situation where they can't afford it. And you've got to target them specifically, those low spenders. You've got to target them and market them in a way that they're going to utilize that and have the ability not to keep using it and building up charges, but just offer a plan.
Right. And guess who wins on that deal? Everybody, right? Because the user gets to use his phone with a clear conscience and know that he's not going to get a bazillion-dollar bill while he's there. The visited guy gets a little bit of that because when he turns his phone off, nobody gets anything, right? So he gets a little IoT revenue from that deal because he had a roamer in that market. And and I think where we're headed with that, Burge, is I think just setting up data packs, we call them, is the tip of the iceberg. That's the easy part. When we get more sophisticated with this, with policy management, and we start really integrating PCRFs, which generally sit in a packet core, but I'm imagining them sitting in sort of the Cineverse network that's between these packet cores, we can go a little bit deeper and only allow certain applications and services to be working. Facebook,
I should be able to set my parameters on a cloud and say, here's what I want to be able to do while I'm away, and not have to worry about.
There is another solution as well that we're finding out. We don't deal with. So we focus more on congestion management at the core, but this is a RAN issue. So there are some companies, but that's a handset-based solution. They put a client, and they're monitoring how many Facebook updates, and they will cache and they will throttle as well. But it's on the handset, so it doesn't even get out of the handset. Yeah, it's an app. Because, it's a RAN issue too, because if it gets out of your phone, then even if you block it at the PCRF level, you're helping your core, but you're not helping your RAN congestion. So there are apps out there that are doing things like that. Not DeviceScape, but there's another company in the Valley. I'll get you their name. Sensa was working with that. Sensa Phil, she's working with them. So
one more thing, our
Chip,
we're
already 5 minutes late, so I guess they're available for questions. We can meet them in the conference, in the atrium, as well as in the conference rooms after the lunch. We need to run, otherwise the media track is going to eat our lunch.
All right.